All right. Well, hello, folks. So real quick, hopefully you are watching this right now on the night that it was assigned, because when you walk in the door tomorrow, which is hopefully tomorrow for you, I'm going to expect that you have some of this stuff written down so that you can make sense of the entry task. Okay. So again, if you're watching this a little bit later, maybe this will help you make sense of what we already did in the entry task. Either way, let's get this information down. So there's a couple things. The primary focus for today is learning how to predict whether certain types of reactions will occur. Now, this is not an exhaustive list, but this is going to help us with certain types of reactions, and we're just going to go over some of the rules. And so one of the things you're going to be asked to do from now on is not just write and balance chemical equations, but before you do so, to predict whether a reaction actually occurs or not. And one of the ways we can predict that is using activity series. So I want you to think back to the lab we did, reacting, the various metals with hydrochloric acid. And as you recall, some of the metals reacted while others did not. So like magnesium and zinc both reacted nearly immediately. Magnesium was a little more violent. But copper, it sat there and didn't do a thing. And you guys started to make some inferences based on that little table I gave you that was labeled activity series of metals. Okay? So before we move forward, though, so a couple important notes. Number one, activity series does not apply only to reactions with hydrogen. We just used that as an example in that lab, all right? So we're not talking about reactions with hydrogen. We're talking about whether one element will replace another, whether it's hydrogen or calcium replacing aluminum or whatever, okay? So that's an important point. We did start with that lab trying to replace hydrogen, but those were just examples to get us thinking about the right kinds of things, okay? And we only use the activity series for single replacement reactions. We have to use different predictors for other types of reactions, okay? So single replacement reactions are what we use the activity series for, and it doesn't necessarily entail replacing hydrogen. It could be any of the metals or non-metals listed on our activity series, okay? So first of all, you're going to get one of these that you can tape to your periodic table, and you can use that on tests and quizzes. You do not need to memorize this, all right? But let's just start delving into how we use this. So here's the basic rule. In general, an element can only replace elements found below it on the activity series chart. So for example, let's say we add aluminum to iron chloride solution. Okay? So this aluminum, if a reaction were to occur, would need to replace that iron, right? Because aluminum is 3+. In this case, the iron is 2+, and the chlorine is a 1-, right? So if a reaction were to occur, right, that means the aluminum would need to replace the iron as a part of a compound, okay? Now, in order for aluminum to replace iron, it needs to be above it on the activity series. So we go over here, we find aluminum, which is right here, right? And we compare the position of aluminum to iron, and we see that iron is down here. Now, so aluminum is above iron. Therefore, we go ahead and predict that a reaction will occur, and we finish out that reaction and balance it accordingly. Okay? Now, let's look at another example. Let's say we add aluminum to calcium chloride. Notice that I noted there would be no reaction there. Okay, so again, we look at aluminum, which is a 3+, calcium is a 2+, chlorine is a 1-. If a reaction were to occur, that means aluminum would need to replace calcium. So we go back to our activity series. Aluminum's here. Calcium, as you will see, is up there. All right? So the rule is an element can only replace elements found below it. So aluminum is not above calcium. Calcium is not below aluminum. Okay? So therefore, we predict no reaction. All right, it's as simple as that. Now, the same thing goes with nonmetals, right? So if we had chlorine, chlorine can replace a lot of the other halogens. Bromine could replace iodine, but could not replace fluorine or chlorine. Okay? that's the way that works. So we'll get some practice with this, but I just wanted you guys to get this in your notes so that we have this part ready to go when we start class tomorrow, okay? From now on, you will need to use the activity series to predict whether single replacement reactions will or will not occur. So from now on, you're going to not go ahead and write and balance your equation until after you've decided whether that reaction should occur in the first place, right? So part of your next quiz will entail that you actually make that decision, right? So if you write out the reaction and balance it correctly, but there's in actuality no reaction, you will not get the points that time. So it's one little layer that you guys are going to have to apply to discern these reactions, okay? Now, the other set of rules, and this is the one that's probably going to give you a little bit more problem, have to do with what's called solubility, whether or not something will dissolve in water. Okay? The rules are a little bit more complex, but again, it just comes down to practice. But aqueous solutions, so if we say something is aqueous, we're saying that consists of water and compounds that are soluble. All right? So aqueous solutions, that entails something that is able to dissolve into water, right? So if we write NaClAq, okay, what that really means in chemistry world, we'll learn to start picturing, is that's actually sodium and chlorine ions, okay, that are more or less separated from each other in that aqueous solution. All right. And by the way, that's why we often put things in water to get a reaction to occur, so that we can go ahead and separate those ions to make the reaction go more easily. Okay? So when we say that little AQ symbol, that means it's aqueous. That means that compound is dissolved in water. All right? Now, not all ionic compounds are soluble. In fact, so we use what's called solubility rules to determine whether or not something is going to be soluble. Okay? So, now, if there's a reaction between two aqueous solutions, we may end up with what's called a precipitate, all right, which would get a little S indication as a solid. Okay? So when there's a reaction between two aqueous solutions, we may end up with one that forms a precipitate, and that precipitate is a solid that forms out of solution. All right, so let's consider the following. Say we have barium nitrate reacts with aqueous, so these are both aqueous, so we have two aqueous solutions. So barium is Ba2 plus, nitrate is NO3 minus, sodium sulfate is Na plus, sulfate is SO4 2 minus. All right, so let's assume a reaction takes place when we do this. All right, so we're going to have Ba NO3 2 plus Na2 SO4 yields, right? So we should be able to tell automatically if this is going to be a double replacement reaction, okay, based on what we learned earlier about how to tell the types of reactions, okay? So if a reaction were to occur, this is my 2 plus, this is my 1 plus, 1 minus, 2 minus, okay? Now, what we learned is a plus always pairs up with a minus, right, when we have ionic compounds, okay? So if a reaction were to occur, that means that we're going to get new compounds on the other side of the reaction, okay? But they still need to follow the rules we learned about ionic compounds. So in this case, our barium and sodium would essentially swap places. All right, so on this side of the reaction, we're going to get NaNO3 and barium sulfate. Okay, so we write our correct equations, right? Then we go back and balance. So I'm going to need a 2 there, okay, to balance that out, and that should do it for us. Okay, now the other bit of information that we're going to start including in all of our reactions, okay, those are aqueous, right? And that's horrible handwriting. I'm going to fix that right now. AQ, Sorry, it's really difficult to write small with this little pen, but that says AQ right there. Okay? Anyways, so those are both aqueous. What we want to learn to do then is to predict whether our products are going to be aqueous or solid. Okay? And what we use for that are what are called solubility rules. Now, you will also get one of these that you get to use on all your tests and quizzes. You can glue or tape it to your periodic table. Okay? And so what we have is a list of soluble compounds and a list of insoluble compounds. And on the right-hand side are exceptions. So essentially, when we say something is soluble, that means it remains AQ. So all of these guys, so if we have a compound with nitrate or with acetate or chlorine or bromine or iodine or sulfate, those are almost always going to be soluble. Okay? The exceptions are when they're with one of these guys, in which case they would become insoluble and would get a little S or solid designation. Okay? So if something is with sulfate, that means it's usually going to be soluble unless it is with sulfates with strontium, barium, mercury, or lead. Okay? Likewise, nitrate says it's going to always be soluble, and there are no exceptions, right? So all nitrate compounds are soluble. So if we look over here, we have sodium nitrate. Nitrate is a aqueous, always going to be soluble, so this gets an AQ designation. All right. Now, sulfate, it says, usually going to be soluble, so that might indicate AQ, except for when it's with strontium, barium, mercury, or lead. And in this case, notice we have our barium ion right there. Okay? So, that means that when sulfate is with barium, it is not soluble, and it gets the S designation. Okay? Now, likewise, sulfides, carbonates, phosphates, hydroxides are almost always going to be solid. Okay? So those will usually get the solid designation. The exceptions make them aqueous. Okay? So for example, carbonates are usually going to be insoluble, but if I have ammonium carbonate, it's aqueous. Likewise with any of the alkali metals, so lithium, sodium, potassium, carbonates, those are all going to be aqueous. All right? I know that sounds a little confusing. We'll get some practice with this. All right? Now, where are we going with this? Again, the point of today's lecture is to learn how we can tell whether reactions are actually going to occur. Okay? So, we talked about how we can use activity series for single replacement reactions. We use solubility for double replacement reactions. And here's the rules, right? So if one or both of the potential products of a double replacement reaction are not soluble, so one or both of our potential products are not soluble, reaction will occur. Okay? So you look at your potential products. If one of them would end up with a little S designation, there will be a reaction, in which case you would go ahead and continue to write the products and balance that reaction. Okay, so you predict, yes, there's going to be a reaction. Now, if all of the potential products are soluble, then the reaction will not occur. So, if everything on the right-hand side gets a little AQ, so everything is soluble, we predict that there is no reaction. Okay? Now, one of the things people forget is sometimes in reactions, one of our products is just water. Right? So in a combustion reaction, for example, and in pretty much all of our acid-base reactions, one of our products is water. Water gets the little designation L, right, for liquid, which is not AQ, but just to avoid confusion, whenever water is a product, right, we then say reaction will occur. All right, and then again, that's usually acid-base reactions, and of course our combustion reactions we learned as well. Okay, so that is the gist of what I want you guys to know. So again, when you walk in class tomorrow, our entry task is going to be about making predictions. I will give you your little copies of your activity series and your solubility rules, with which you can go ahead and quickly take those to your periodic tables. And again, you get to use those on all the daily work, all your tests and quizzes as well. All right, you just need to know how to use them, which will come with practice. All right, I'll talk to you tomorrow.